Same is the case for the SW instruction. So SW instruction will execute in the same way. It will follow the same path. It's fetched from the instruction memory, then it will reach to the instruction decode phase, and then when it is being in the execution phase, so after being executed, it will calculate the address. Of course, one input of ALU is coming from the register file, and the second input is coming from the immediate data. So it's being added together to calculate the address, and once it reaches to this point, so you see the data has to be written at the address specified by ALU. But what data, where this data is coming from? So if we would not have the pipeline register, it will be fetching the data from the instruction which would be in this path, which would be in this stage. So if again it could be, let's say, add x1, x2, and x3. So x2 is the rs2. Whatever the data is available here, it will be written back. It will be written to the memory at the address here. However, SW might be writing into some another register. So it writes to the correct register contents. Why? Because we also fetch the data and store it and fetch the data of rs2 when the SW instruction is in this phase, and store the data into XMEM register. And then while writing it back, so this the writing process will fetch the data from this register rather than fetching the data directly from the register file. Okay, so SW, there is no point of having the write back phase in SW. So SW instruction actually finishes up here, so that's why no component is highlighted in this phase. So this is a single cycle execution of an instruction in the pipeline architecture. We have also talked about the multi-cycle pipeline diagram, where the every instruction's data path is plotted separately. So here, the instruction memory, you have already seen this a couple of times before, that would be pipeline register. So once this instruction is in the second phase, ID, which is the instruction decode phase in the register file, in clock cycle number 2, the next instruction will be in this instruction memory phase, and so on and so forth. So this is easier way of analyzing, but it does not give you more details about what is happening in the instruction. And we can also analyze the cycle diagram in this way. So instead of having the visual components like this, you may also be given a diagram like this, where you are specified with the name of the stage: instruction fetch, instruction decode, execution, and so on and so forth. Okay.